Right. Today's lesson is 11-6. This will be part A. Our objective is to simplify radical expressions with numbers and variables in the radicand. A radical expression is the expression that contains a radical sign. You guys are used to seeing these as a square root, but it's actually a radical symbol. They're not all square roots, and we'll look at that in part B. So right here, if there's a little number right here, it's called the index, and if there's no number there, it's an understood 2. The number and variables underneath the radical symbol is what's called the radicand. Okay, and again, this is the radical sign, and the whole thing is a radical expression. Review of square roots. Remember that positive numbers have 2 square roots, one positive and one negative. However, a square root indicates a positive square root. You don't have to write down these examples. We just kind of want to look to give you an idea of what we're doing. 16 is going to break down into 4 and 4. So that's why the square root of 16 is 4, because you have 2 4s and an index of 2. Same thing with 25. 25 breaks down into 5 times 5. My index of 2, I have a pair or 2 5s, which is why my answer is 5. The square root of 25 is 5. Square root of 36 is 6, because 36 is made up of 6 times 6. Again, 81 is, the square root of 81 is 9, because 81 is made up of 9 times 9. There's a pair of 9s here. So that's what we're going to be looking for. We're going to be looking for pairs of the same number, just like we've looked at here. A radical expression is in simplest form when the radicand has no perfect square factors other than 1. So the square root of 9 would not be in simplest form, because the square root of 9 is 3, so that can be simplified some more. The radicand has no fraction, so I'm not allowed to have a fraction underneath my radical symbol. And I'm also not able to have a radical expression in my denominator of my fraction. So I can't have a radical expression in the denominator, I can't have a fraction in the radical symbol, and again, I can't have no perfect square factors. We'll need to use prime factorization to simplify radical expressions. We're going to use a method called the birthday cake method to find out our primes. Now your primes are written right here. I need you to write those on the top of your paper. 2, 3, 5, 7, 11, and 13. There are more, but usually up to 13 is about all we use. So please make sure you have those written at the top of your paper. Prime numbers, 2, 3, 5, 7, 11, and 13. The birthday cake method involves dividing the number by a prime number and continuing to divide by a prime until you get the 1 or the candle on the top of your birthday cake. So like here, I'm going to take 28, and I can use any of these prime numbers. I usually start with the smallest one, so if it's even, I start with 2. Now divide. 28 divided by 2 gives me 14. 14 can again be divided by 2, and I get 7. 7 divided by 7, there's the 1 or the candle on my birthday cake. The 1 tells me that I can stop and I'm finished. So instead of 28, 28 is made up of 2 times 2 times 7. Those are the prime numbers that it's made up of. Now we're going to actually take this birthday cake and turn it upside down, and this is the way you're going to see it written on your examples. You don't have to write any of this other than the prime numbers at the top. But we're going to go down so that we don't end up in the problem before it, as far as space to actually work our problems out. All right, go ahead and write down number 1. We have 2m square root of 16m to the 5th. Now again, we talked about how if there is no little number right here for an index, it's automatically a 2. So I'm just going to write in a little 2 for our index of 2. Now, I don't have to worry about the 2m that's on the outside right now. I just need to worry about the 16 on the inside. So I'm going to take 16 and I'm going to do the upside down birthday cake method. Alright, so let's go ahead and with number 1, again you have 2m square root of 16m to the 5th. And we're going to birthday cake 16. I went ahead and wrote my prime numbers up at the top so that I know what numbers I'm allowed to divide by, because those are the only numbers you're allowed to divide by. So with 16, again, I can only pick from these numbers, and I can divide by 2. 16 divided by 2 is 8. So then I'm going to pick another prime number to divide by 8, and that'll be 2 again, and I get 4. I can divide 4 by 2, and I get 2. Divide 2 by 2, and I get 1. So there's the candle on the top of my birthday cake. Now you have to be careful when you see 16 here. You can't say, oh, well, I'll divide 16 by 4. 4 is not on your prime list. You can only divide by the numbers in this list right here. And again, you're going to keep dividing until you hit the 1, and that's the candle on the top of your birthday cake. So I'm going to go back and rewrite this. I'm going to write 2m square root, and instead of 16, I'm going to write what 16 is made up of, and I have 1, 2, 3, 4 2's. And then I have m to the 5th. So with the m to the 5th, I'm going to write down 5 m's. Now that I have everything written out, I know I have an index of 2 since it's a square root, so I'm going to look for pairs or groups of 2 that are the same, and I'm going to circle them. So I have a pair of 2's, I have another pair of 2's, I have 2 pairs of m's. So everything I'm circled I'm allowed to take out, because if I look at this, 2 times 2 is 4, and the square root of 4 is 2. So I'm going to bring down this 2 and this m. I'm going to bring out a 2 from the pair I circled here. I'm going to bring out a 2 from the pair that I circled here. And then I'm going to bring out 2 m's since I circled 2 m's. And then I'm going to have my square root, and I have to leave this poor little m right here. He doesn't have a pair, or he doesn't have a group of 2, so he has to stay. So now I'm going to multiply everything on the outside. 2 times 2 times 2 is going to give me 8. Then I have m times m times m, which gives me m to the 3rd. And then I have my square root of m. So there's my simplified radical. 8m to the 3rd square root of m. Please make sure you have all of that worked down before you move on. Right, go ahead and write down number 2. We have the square root of a to the 5th, b to the 6th. With this one, I don't have a number underneath my radical symbol, so I don't have anything to birthday cake. So here, I'm just going to write out my 5 a's. 1, 2, 3, 4, 5. I'm going to write out my 6 b's. 1, 2, 3, 4, 5, 6. So I wrote out 5 a's and 6 b's. I know I have an index of 2 here, so I'm looking for pairs or groups of 2. So I have a pair of a's, another pair of a's, and I have 1, 2, 3 pairs or groups of b's. So again, every time I circle something, I can take one of those on the outside. So I'm going to pull out this a from here. I'm going to pull out another a from this group of a's. And I can pull out 1, 2, 3 b's since I have 3 groups or 3 pairs of b's. And then I still have my square root symbol, and I still have a little a right here that's not been circled, so it has to stay underneath the radical. Clean this up just a little bit. A times a is a squared, and b times b times b is b to the 3rd square root of a. Please make sure you have all of that written before you move on. All right, go ahead and write down number 3. We have the square root of 108, f to the 4th, g to the 2nd. So this time I do have a number underneath my radical symbol, so I need to come over here and upside down birthday cake 108. Now again, I can only divide by these prime numbers up here, so I'm going to pick one. I could either pick 2 or 3 because both are divisible here. I'm going to pick 2 because again, I like working from the smallest prime that I can first. So 108 divided by 2 is 54. Then I'm going to take 54 and divide by 2 again, and I get 27. Now I can't divide 27 by 2 because it's not even, but I can divide 27 by 3 and it's prime. So 27 divided by 3 is 9. I can divide 9 by 3. 9 divided by 3 is 3. And I can divide 3 by 3 and I get my 1. Now when I get to the 1, I know that I'm done with my upside down birthday cake. So I'm going to rewrite this, and instead of 108, I'm going to write 2 times 2 times 3 times 3 times 3 from the outside of my birthday cake. So I have 2 2's and 3 3's. I have 4 F's and 2 G's. 2, 3, 4, 1, 2. So I have everything written out in its primes here, and I know that this is again a square root, so I'm looking for pairs or groups of 2. I've got a pair of 2's, a pair of 3's, 2 pair of F's, and a pair of g's. So I can take all that out. So I can take out a 2, a 3, 2 f's, and a g. And I have square root of 3 left because I have this one little 3 right here that's not been circled, so it has to stay underneath the radical. Then I'm going to multiply 2 times 3 here is 6. F times f is f squared. G square root of 3. And that is my final answer. Please make sure you have all of that written down before you move on. All right, go ahead and write down number 4. We have square root of 6 times the square root of 14. Now here I have 2 square root symbols. Anytime you have 2 square roots and you're multiplying here, and since those are right together, they're being multiplied, this only works with multiplication, but if they're being multiplied, I can just simply put them all underneath one big square root. So the 6 and the 14 are going to go underneath one square root. Now I can either birthday cake the 6 and then birthday cake the 14, or I can multiply them together and birthday cake the big number that I get when I multiply those together. So I'm going to birthday cake them separately. So I'm going to come over here and birthday cake 6. And I can divide 6 by 2. Again, I have to make sure it's a prime. 6 divided by 2 is 3. 3 divided by 3 is 1. So there's my birthday cake for 6. I get a 2 and a 3. Then I'm going to come over here and birthday cake 14. So I'm going to say 14 divided by 2 is 7. Well, 7's prime, so 7 divided by 7 is 1. So there's my candle. So here I have a 2 and a 3 and a 2 and a 7. And I like to put my numbers together that I like. So I'm going to put 2 times 2 and 3 times 7. I don't have to worry about the ones. That's not going to make any difference. The ones just tell me that I'm done with my birthday cake or I'm done with my primes. So now I can circle my groups or pairs, and I have a group of 2's. So I have a 2 square root. Now I can't pull out the 3 or the 7 because again they don't have a pair or a group and they're not being circled. So I'm just going to multiply those back together and say that 3 times 7 is 21. So I have 2 square root of 21. That is my final answer. Please make sure you have all of that written down before you move on. All right, go ahead and write down number 5. We have the square root of 2x squared over 18x. These are a little bit different. The other ones are pretty simple as long as you get the birthday cake method and know that you're supposed to circle your pairs. Where it gets complicated is right here with our fractions, because we talked about in the beginning, I'm not allowed to have a fraction underneath my radical. So the first thing I'm going to do whenever I see a fraction is I'm going to see if there's anything in that fraction that I can reduce. And I can put in 2 over 18 into the alpha y equals of my calculator and find out that it's 1 over 9. So I already reduced that to 1 over 9 instead of 2 over 18. I also have x's on the top and bottom. And we talked in chapter 12 about how if you have the same thing on the top and bottom, you can cancel. So instead of x squared, I'm going to write that as x times x. And I can see that this x and this x are going to cancel. So now I'm going to clean this up a little bit. And I have a 1x on top and a 9 on the bottom. Once I've completely got done simplifying, then I'm going to go ahead and split this up and say the square root of x, or 1x, and the square root of 9. So here, if I'm looking at this, I no longer have a fraction in my radical, but I'm not allowed to have a radical in the denominator. So I need to get rid of this. And it just so happens that the square root of 9 works out because the square root of 9 is 3. Now if I don't know that, I can come over here and birthday cake 9. And I get 3 times 3, so I would have a pair of 3's with nothing left under the radical, so I wouldn't need it anymore. So this one works out. The square root of 9 just happens to be 3, so my radical gets rid of itself. And on the top, I have to keep the square root of x. And I'm allowed to have the radical in the numerator or top of the fraction, just not the denominator. So that is your answer to number 5. Please make sure you have all of that work down before you move on. Okay, go ahead and write down number 6. We have the square root of 1 over 49n squared. Now again, like I said, make sure that you can't reduce, and here I can't. 1 over 49 does not reduce, and I don't have any n's on the top to cancel with my n's on the bottom. So since there is nothing to reduce here, I'm going to go ahead and split it up and say the square root of 1 over the square root of 49n squared. Now I can look at that and just know that the square root of 49 is 7 and the square root of n squared is n, and if you can do that, that's fine. If not, I'm going to come over here and birthday cake 49 and I get 7 and 7. So I could rewrite this as 7 times 7 and then n times n. And I have a pair of 7s and a pair of n's. So I don't have anything left underneath my radical at the bottom, so I just have 7n. And my radical actually goes away in the top too, because the square root of 1 is just 1. So I end up with 1 over 7n. So make sure you have all the work down for number 6 before you move on. All right, go ahead and write down number 7. Number 7 says the square root of x divided by 3. So again here, I'm going to do the same thing. I'm going to see if there's anything I can reduce in there, and there's not. I can't reduce x over 3. So I'm going to go ahead and split up and say the square root of x over the square root of 3. Now in these other two examples up here, I had pretty numbers at the bottom, meaning I had perfect squares in the bottom, so my square root got rid of itself. 3, however, is prime. I can't birthday cake 3 because I only get 3 back out, and the square root of 3 is not a pretty number. So what I'm going to do is I have 1 3, and I need a pair in order to be able to circle, or a group of 2. I have 1 3, I need one more in order to make that group or pair. So I can multiply the bottom by the square root of 3 to get the other 3 that I need, as long as I also multiply the top. So on the top, I'm going to say I have the square root, and I'm going to put my numerators together and say the square root of 3x. And in the bottom, I'm going to say it's the square root of 3 times 3. Now I have that group of 3 that I need, and I don't have anything left underneath the radical at the bottom that's not been circled, so it's just 3, because 3 times 3 is 9, and the square root of 9 is 3. And then on the top, I just have the square root of 3x. Now normally I would look to make sure I couldn't birthday cake or simplify in the numerator any farther, but 3 is prime, so I can't. So it's just the square root of 3x over 3. Also be careful, I can't cancel out these two 3's because this isn't 3, it's the square root of 3. That's completely different than being a 3, so don't mark out those 3's. It has to stay just like that. Square root of 3x over 3. Make sure you have all of that work down before you move on. All right, go ahead and write down number 8. We have the square root of 2d over 5. Again, I'm going to look to see if I can reduce, but I can't. 2 over 5 can't be reduced, and I don't have any d's on the bottom. So I'm going to go ahead and split it up. That's my second step after I see if I can reduce. And then I'm going to look to see if this turns out nice. The square root of 5 is not going to turn out nice. That is not a pretty number. It's not a perfect square. And 5 is prime, so I can't come over here and birthday cake it. So here I have 1 5, and I need one more in order to make that group of 2, or that pair of 2. So I'm going to multiply the top and bottom by the square root of 2, because I can do that as long as I multiply the numerator and the denominator. So in my numerator, I'm going to have 2 times 5 times d, and I just like to put my numbers together. And on the bottom, I'm going to have the square root of 5 times 5. There's my group of 5's. So my square root cancels in the bottom, which is what I wanted it to do, because I'm not allowed to have a fraction in the radical. I'm not allowed to have a radical in the denominator, and I got rid of it. Here, 2 and 5 are both prime, so I can't birthday cake those, so I'm just going to multiply them back together. 2 times 5 is 10d. So I have the square root of 10d over 5. Again, don't reduce 10 over 5, because this isn't 10, it's the square root of 10, so just leave it exactly the way it is. That is my final answer right there. Please make sure you have all of the work down before you move on. Your homework's at the top of the page. Please make sure that you pause the video and get that homework assignment written down. Once you have your homework assignment written down, this is the end of your video. Thank you for watching.